Moving on, let's now look at the distance between two lines in two dimensions, also known as R2. Before moving on to considering the distance, we must first consider the possible situation of two lines in a plane. Firstly, two lines will either be parallel or non-parallel. We know that two lines are parallel if their direction vectors are parallel, collinear, or scalar multiples of each other. If the two lines are parallel, then only two situations are possible. The lines will either be parallel and distinct or parallel and coincident. The difference between these two cases is that two distinct lines share absolutely nothing, whereas two coincident lines share everything. However, if lines are non-parallel, then they will intersect at a point. This is always true in R2. As long as the direction vectors of two lines are not collinear, then the two lines will intersect. Now, recall once again that distance is the shortest straight line path between two things. Let's evaluate the distance between two lines in each of these three cases. A. If the two lines are parallel and distinct, then the distance between them will be a line like this, which is normal to both lines. B. If the two lines are parallel and coincident, there is no distance between them because they share all their points. The distance between them is 0. If the two lines are non-parallel, they are intersect. There is no difference between them because the shortest path between them will be at the intersection point. The distance between them is 0. Hence, we can only calculate the distance between two lines if they are both parallel and distinct. Let's take a look at an example of the distance between two such lines. Let line L1 be xy equals to 0 minus 1 plus t21, and line L2 be xy equals 37 plus t21. Given that the two lines are parallel and distinct, what is the distance between them? Well, to do this, we simply repeat what we did in the previous section. The distance between the two lines can be calculated using a vector projection. To calculate length using a vector projection, remember that we need two things: a vector PQ between any 2 points on the line, and a vector N, a normal to both lines. To find PQ, we can simply use given point from each vector equation at the line. Let P be 0 minus 1 and Q be 37. PQ will be just 38. Then, a normal can be found using a method previously mentioned in this video. We take the direction vector 2, 1 and swap the x value and y value, then add a negative sign to one of the values. So, vector n can be minus 1, 2. Now, we are ready to calculate the distance between L1 and L2. The distance will be the projection of PQ onto n. So this will be equal to the dot product of 3, 8 and minus 1, 2 divided by the magnitude of n. The square root of negative 1 squared plus 2 squared. In decimal form, the distance between L1 and L2 is about 9.8.
Created using Powtoon.